Just some announcements about this week. Obviously, we've got the 4 meetings, just like we always have 4 meetings for 50 minutes each, but then you'll be dismissed to lunch and then that will end the day. I'm thinking that I would like to give you tomorrow as kind of a work day. So I think we'll finish up lesson 14.4 today. And then tomorrow you can just come on in, work on what you need to work on. I don't think we're going to do anything new tomorrow. Is that okay? It's okay. All right. I suppose, Mr. Gingrich, we really want to do new math, but all right. Excellent. So we're going to finish up today the tangent problem and the derivative. And actually the kind of the concept today is another concept of a derivative. So we've looked at the fact that the slope of a tangent line is a derivative. You can also use a derivative to find the rate of change at a specific point on a function. And that kind of leads us to what we're going to do today, which is instantaneous rate of change. Now, I personally wouldn't copy this whole thing down. I would maybe jot down the height, the height S of a ball is, and the equation, because I think we've worked with this in the past. Hopefully you have. And we're going to actually answer, I think it's 8 questions about this specific situation. All right, so when does the ball strike the ground? That is, when or how long is it in the air? So for that problem, we're going to take our equation and just set it equal to 0. Again, you could use the quadratic formula. You could look at a table of values. This one actually factors. There is a common factor of -16 that comes out. And so this factors into t minus 6, t plus 1. And we cancel or we throw out or we ignore the t equals -1. Basically saying 1 second before the ball is thrown, it hits the ground, which doesn't make much sense. But it is in the, the ball is in the air for 6 seconds. At what time will the ball pass the rooftop on its way down? So again, we're going to take our equation and set it equal to the height of the rooftop. And the height of the rooftop is 96 feet. And solve. So the first thing I would do is subtract 96 from both sides. Now I have a common factor of 16 and t. Set each of my factors equal to 0. So on the way down, that is the key here. It doesn't pass the rooftop on the way down at 0 seconds. That would be right before the ball is thrown. It passes the rooftop on the way down. That doesn't really make sense in this problem, but I think the t equals 5 does make sense. So that would be at 5 seconds. Which maybe makes sense if we go back to this first problem. We had t equals -1, so -1 second for the ball basically to go from the rooftop to the ground, or 1 second of the 6 that it's in the air. So that means at 5 seconds, it would cross the rooftop. So far, nothing to do with derivatives or anything. But now we get to do stuff with derivatives. What is the average speed of the ball from t equals 0 to t equals 2? So I'm going to write my equation down again, if I can remember it. So the average speed, I would take s at 2 minus s at 0 divided by 2 minus 0. And I think it's just easiest to use our calculator to do some of these calculations. I'm pretty sure 2 minus 0 is 2, though. I'm pretty confident on that one. And if I plug 0 in for t, so s of 0 would be 96. And I'm subtracting that s of 0. But s of 2, I'm not quite sure about. So that one would make sense to have the graphing calculator or some sort of calculator. So oops. And at 2 seconds, it's 192 feet in the air. So we'll put that in. Ooh. And I think 192 minus 96, I think that is 96. Half of 96 will be 48. And that represents feet per second is the average speed over the first 2 seconds. Now the fun starts. I know you just can't wait, I can tell. Find the instantaneous speed. Now, to be honest, in physics and in calculus, we don't say speed. Normally we say velocity. Find the instantaneous velocity of the ball at time t equals 0. And the reason is speed is only measured as a positive value. You know, I don't think anyone says when they're backing up that they're going negative so many miles per hour. Okay, same thing here. So our textbook uses the word speed. That's why I used it here. But just so you know, velocity is much more common. To find the instantaneous speed or velocity, we're going to take the limit as t approaches t sub 0 of s of t minus s of t sub 0 over t minus t sub 0. So the limit as t approaches t sub 0 of negative 16t squared plus 80t plus 96 minus, and I'm going to put this in parentheses, negative 16. Instead of t, it's going to be t sub 0 squared plus 80 t sub 0 plus 96 all right. And then I'm going to distribute that negative through. And I'm doing this probably more for my benefit than for yours. I just want to make sure I get the signs all correct. Okay. One thing you might notice, we have plus 96 and minus 96. Those cancel. That's kind of nice. The rest, what I'm going to do is group them together. So I'm going to take the limit as t approaches t sub 0. And that's plus 80t minus 80t sub 0 over t minus t sub 0. Some people just read that t naught. I like saying sub 0. And what I'm going to do is that first quantity, I'm going to factor out a negative 16. So I have negative 16, and that would make it t squared minus t sub 0 squared. And the second quantity has a factor of 80. And that should be 0, not a 2. I don't know what I did there. And believe it or not, we're almost done. This t squared minus t sub 0 squared is a difference of squares, and that can be factored. Negative 16. T plus t sub 0, t minus t sub 0, plus 80 times t minus t sub 0. Now, there's a common factor of t minus t sub 0 in both terms in the numerator. And that's going to be very helpful. So I'm going to factor that out. Oh boy. Sub 0, not superscript 0. Common factor cancels out. And now if I plug in t sub 0 for t, I get negative 16 t sub 0 plus t sub 0 plus 80, which would be negative 32 t sub 0 plus 80. So that's the instantaneous rate of change at any time t sub 0. It's a lot of work. But we feel good having done it, right? All right. So now we're going to ask some questions. What is the instantaneous speed or instantaneous velocity at t equals 2? Well, we already know the instantaneous speed at any time is going to be negative 32 t sub 0 plus 80. So to find the instantaneous speed, we're just going to plug 2 in for t sub 0. And we get 16 feet per second. When is the instantaneous speed 0? So just take negative 32 t sub 0. And you really don't have to write the t sub 0. You can just leave it as t, which I'm going to do from now on because, hey, if I don't have to write that extra subscript, I'm okay with that. Solving for t. And t would equal 5/2 or 2.5 seconds. So what that means is at 2.5 seconds, the ball for just an instant stops. See, they want to take a picture of Mr. Gingrich in his nice uniform. Yeah. Can you give me like 2 minutes?
Yeah.
All right. So the ball, you throw the ball up, it reaches, that's actually where it reaches its maximum height, and it stops for just a split second, and then it starts to fall. All right. What is the instantaneous speed when the ball as it passes the rooftop? Remember, we said that happens at 5 seconds. So we can use our formula, negative 32 times 5 plus 80. And there we see that negative speed. That's why I call it velocity. The negative just means it's falling and it's just moving downward rather than moving upward if it was positive. And what is the instantaneous speed when it strikes the ground? Now, don't be smart and say 0, Mr. Gingrich, because when it hits the ground, it's not moving anymore. They mean like right before it hits the ground, how fast is it moving? And that happens when t equals 6. We found that as well in the beginning of the problem. I shouldn't have had that equals 0 up there either. So this is negative 192 plus 80, negative 112 feet per second. Whew. Fun, right? Yes, Mr. Gingrich, we love this. Can we do some more? Well, I tell you what, here you go. You can do a couple problems. That's what you can do for, only 2 problems. But the first one, I think, has 6 or 8 parts to it, just like this one did. And then 48, I think, is just 5. I think it's A through E on number 48. So, but that's the deal.